Great. I think we should get started. So first of all, I'd like to do an introduction. So my name is Wenming Yi. I'm a senior technical product manager. It's a little hard for me to read this just because it's my new job. I've been on the job for about a month. So I joined Rachel's team. Her team is so awesome that I decided to join her team. So Rachel is a applied scientist on my team now, and she is well known for her MLU or Machine Learning University content that's on YouTube. So Amazon has a machine learning university that we teach internal engineers machine learning. And Rachel is the person that recorded a lot of those videos. I've been at Amazon for about 4 years, and I understand that a lot of these conferences, folks are looking for to learn about machine learning and looking to get insights on how we do things at Amazon, as well as interested in career opportunities. So definitely, ping me if you are interested in positions at Amazon, and we're very happy to help you find the right position. It is definitely a time where machine learning is it's a very exciting topic, and we have lots of positions open at Amazon, and my understanding there's quite a few of those in Canada as well. So feel free to reach out to me if you need any guidance on that. So first of all, here's our list of objectives. We have about 2.5 hours, and I think we have run this lab for maybe this is the third time we've run it. We previously ran this at KDD. That was the first time when we fixed a bunch of bugs, and we fixed a bunch of more bugs. We ran them for PK KDD that was in EMEA or Germany, and this is the third time back in North America. So I think we fixed a few of these bugs. It should take somewhere between 2.5 hours to 3 hours. In addition, I'll keep the lab environment open. So for those of you who are interested in exploring AWS a little bit more, and we'll be giving out an anonymous account for everyone. And you can experiment with other parts of the EC2 environment, or just play more with SageMaker. We'll keep it open for an additional hour or so. So the objectives are understanding AI/ML industry trends. So I've been at AWS for about 4 years. I work a lot with internal and external customers. I understand a lot of their pain points. So I'll be happy to share some of that. And then we'll go do an overview of machine learning tools at AWS. This might be very useful to you to take advantage of some of the innovations we've done on AWS. And also, your employers may actually ask for those skill sets. There's ultimately a machine learning training and certification that you can get from AWS. It's relatively easy. I would encourage folks to get it if you have an opportunity to. And then we will do an introduction to NLP, or specifically the BERT deep dive. Rachel will walk you through that, and she has very detailed slides on how BERT works, and machine learning model architectures are similar to that. And then, of course, we're going to give you some hands-on experience that you're not likely to get anywhere else. And we will be essentially taking a BERT model, train it on a four GPU systems, and then you will help you to walk through the deployment process. So the entire lab is 18 lines. It's really, I would say it's relatively easy to be able to do training and deployment on systems like SageMaker. And certainly we're not, forcing you to use SageMaker. You're very welcome to use existing systems or EC2 directly. In fact, that's what a lot of our customers actually use. I also have an announcement on one of the newer GPUs that we've just made available. It's called the P4D instance, or the Ampere or A100 instance type from NVIDIA. So this is the fastest GPU available today on AWS. and in the industry, and that has 40 gigabytes of RAM and 2.5 times faster than our existing P3 or the Volta architecture. And here's the agenda. We'll do the welcome and the logistics. So all the code and is in the GitHub. All the instructions are in GitHub. So just copy this URL or take a picture of it, however you like. And we'll give you another opportunity to walk through the lab. So the lab is instructor led. We won't leave anybody behind. And then we'll do the AIML overview, the transformers. We'll do the lab. The lab training does take, it's a real actual training of fine tuning of a BERT model. So it's going to take 4 GPUs, about 40 minutes or so. So you're going to have an opportunity to take a break and ask questions. All right, so let's get started. So the first thing I want to point out is that there's an exploding model complexity in the industry. So how did we get here? I would say in 2013, 2014, I was actually at Microsoft Research at the time. ImageNet was a big breakthrough because we suddenly had this data set that we can actually train models on. ResNet 50 also came out of MSR by a guy named Sun Jian, and he essentially did a breakthrough by having these very deep neural nets to be able to train and get really good performance out of ResNet. So of course, there's a lot of different variants of ResNet, and that goes from 18 layers to 50 layers to 152. And of course, there's new variants today. So that was the breakthrough where people were starting to see that there's a above human performance, human level performance for these machine vision models. And as you can see, it always starts with a data set. And then we started having even more innovation out of the natural language processing. And there was a team out of Google that actually all of them were from Microsoft Research originally. So as you can see, most of these innovation actually all comes back originally from MSR. The BERT model was invented, and that kind of just really changed everything. And then we started having innovations from GPT-2 all the way to GPT-3. Microsoft also has another one called the Turing NLG, which has a 17 billion parameter. And of course, there's the most talked about model, the OpenAI GPT-3 model, which I actually personally tried. It was quite interesting on what it can do. But of course, as these models get bigger, the ability to deploy them becomes, I would say, even harder. So today, a lot of our customers have trouble even deploying BERT models because of latencies and other issues that they run into. So at 175 parameters, it's almost, I don't think anybody would be able to deploy that in production at scale. So currently there's these GPT-3 small models that are being deployed, and OpenAI has publicly, you can apply for access to it. Okay. So machine learning use cases, and there's a phrase at Amazon called day one, which is you're just starting and you are very excited about the field, and people are learning. There's a lot of excitement about machine learning. So I like to use that as the, I would say, metaphor for machine learning. Machine learning, we're at day one because people are still trying to figure out how to use machine learning to apply them to real world problems, both at scale and at very economically. So it starts by looking at natural language processing and image processing. So these are the bread and butter, and everyone has been working on these two scenarios. And of course, then when it comes to vertical fields, people are starting to apply that towards, as always, financial services companies, and they always have a lot more, I would say, resources to be able to do that. Healthcare and life science, typically there's a lot of research that happens in this field, and that definitely is a field where deep learning is being applied to. Manufacturing is always about scale. when you are doing things at scale, every little penny counts. So being able to apply machine learning and deep learning to optimize your manufacturing process is another great area of machine learning to be applying to. Autonomous vehicle is one of those areas where we would call them as the field of which you continue to spend time and effort on to advance the state of the art. And if you look at a lot of the papers coming out of NVIDIA and other places, actually, you guys have a great research lab in Toronto. So if people are starting to work on more practical pieces of machine learning. So for example, reducing latency from 100 millisecond to 7 millisecond. There was a recent paper by NVIDIA to be able to do that requires tremendous amount of engineering effort and know-how. Recommendation systems is something that we have been using quite a bit at Amazon. So more recently, we're working on things like taking these language models and taking the embeddings to feed into these recommendation systems to make things even more accurate, being able to use graph networks and product graphs to be able to really show demonstrate the embeddings to be much more effective when it comes to building these recommendation systems. Essentially a way of making sparse matrices work a lot better. And of course, there's retail, hospitality, among other fields where deep learning and machine learning truly can apply things to. So if you're not one of the deep learning, machine learning, I would say architecture researcher, you'll probably be working on one of these verticals in the near future. So back to AWS ML stacks. AWS machine learning team started by basically taking some of our best applied scientists from Amazon.com side. And we formed a team about, I would say maybe 4 years ago. And we started looking at how can we actually bring the machine learning capabilities to the hands of developers and research and also machine learning scientists. So we looked at being able to allow different personas to be able to take advantage of the stacks. First of all, we have the AI services. A lot of these are backed by open source libraries, such as the ones that you see at the very bottom. So we mostly build everything on MXNet. And we have a lot of models that we custom train with the data sets that we have. Another area of focus is text and NLP. So if you don't want to train your own models, these are essentially things you can take out of the box and be able to use directly. So of course, there's a convergence between these stacks from the machine ML services, meaning building your own models, and AI services, which you just simply call an API. So these AI services at the very top layer, they're starting to allow you to train with your custom data. So there's going to be a convergence between these two covered gaps when it comes to operationalizing your machine learning services versus building your own and operationalizing it yourself. Okay, so of course there's a lot of new services that we're going to be announcing at reInvent. I'm not going to do any pre-announcements. I'll let Andy Jassy do that, and we will have probably another few hundred of these machine learning services that will be announced. But here, the existing ones includes personalization. That's the recommendation systems, and fraud detection, which works really, really well. In fact, we'll have some new services coming. And of course, there's Code Guru, which turns out to be very useful for our developers to catch code bugs and among other things. So I pushed that very hard internally for teams to actually use. The second layer here is the ML services. Essentially, you're bringing your own machine learning models. So the idea is that it allows you to be able to take a notebook instance, be able to build a model, build your IPython notebook, do the training, distributed training for a relatively large scale. I wouldn't say it's like not thousands of machines, but maybe tens of machines, you will be able to do that. But in the future, you probably would be able to do that with thousands of machines when we enable EFA. Um, and EFA is a way for the underlying networking to communicate efficiently using RDMA, or direct memory access. It has notebooks, experimentation, comes with debuggers, autopilot, which is an AutoML service that's built in, and there's model hosting. So essentially, you will be doing that lab yourself. So if you were to do all of this by yourself, you kind of have to worry about, spinning up the machines, working on permissions, making sure that the pipeline is built properly with the right software to be installed, and of course, being able to host it with the right load balancer. So that's going to take a little bit of work. So all of that is taken care of by Amazon SageMaker. So at the very bottom layer, we support all the different open source frameworks, TensorFlow, PyTorch, pick your favorite. Also, there's a set of libraries. So Deep Graph Library is one of them. There's also something called AutoGluon and Gluon time series. And all of these things are essentially tools that we've open sourced. And many of these tools are used internally at Amazon and have gotten really good results at Kaggle and other, winning other competitions like M5, which is a competition for time series. And of course, there is a lot of hardware support that Amazon provides. That includes our latest inference chipset called Inferentia. And of course, the P4D instance type that I just mentioned that is based on the A100 GPUs from NVIDIA. So as you can see, if you were to train your machine learning models using our latest hardware, here's some of our recommendations. So P4D, that is available to you now, and it's generally about 2.5 times faster than the previous generation. That's according to NVIDIA, and it has about 40 gigabytes of RAM rather than GPU RAM, rather than 16 and 32 on the previous generation. And of course, there's the T4 instances, which are the NVIDIA P4 instances, T4 instance GPUs, and they're very cost effective when it comes to running inferences. And they're very inexpensive as well. So I can give you an example. I think the P4D is about $4 an hour per GPU. And if you use spot instances, which is essentially the spare capacity we have, you get about 70% off. And for the G4 instances, it's about 50 cents. So it's actually much cheaper. If it's a great instance type for inference. And of course, we've built our own ASIC, or application-specific integrated circuit chip that's specific for inference. And you would be able to get really good performance on that. That's even cheaper, but the caveat is that it's going to take you a little bit of time to tune for the Inferentia chip. So it's not going to be as easy to use as the general purpose GPUs when it comes to building an inference pipeline. Okay, so SageMaker. So SageMaker has, I would say, was announced in 2018, I believe. Yeah, so essentially we have these built-in notebooks that you can use. And it's essentially Jupyter Lab or Jupyter Notebook. We also have something called SageMaker Studio, which is kind of another more integrated version of it, but that's still mostly under development. So it's not as stable as the classic notebook instances. So I would recommend that you use the classic notebook instances. And of course, when maybe come back and try that in a couple of months, and SageMaker Studio would probably be working a lot better. And then there's the built-in algorithms. We provide a set of built-in algorithms for the convenience of our customers. They're fully supported. You can do one-click training. So the training is actually quite easy. All you have to do is to run an estimator. You pretty much have, we're going to be going through that with the lab. And of course, there's, deployment is another big piece. I think, is it 2/3 or 1/3? I don't remember. So I think it's 1/3. Might be 2/3. Yeah, it might be 2/3. 2/3 of our, a lot of internal users, I look at their revenue spend. So they are spending it on deployment. So that kind of makes sense, right? So when you're running the notebook and the training process, it doesn't take you repetitively to do this, but when it comes to deployment, your fleet is always running, right? So that's why, I would say 2/3 of the money is usually spent on deployment for these things. So I just wanted to talk a little bit about deployment. So you would be building most of your model is inside Jupyter Lab. And it's pretty easy to use. It's pretty much the standard Jupyter Lab that we have. And then once you're done, you'll deploy that into production. So SageMaker makes that relatively easy to do. So once you deploy, there's many different ways of configuring it for scaling up and down, as well as supporting multi-model, meaning that you can give it 1,000 models and it will load and unload the appropriate one when it comes to running things in production. So offers you a lot of different flexibility. So another feature which I think is worth noting is the labeling or ground truth. Ground truth allows you to label things that are, from very simple to very complex models. So it has, you can do bounding boxes, you can do a checkbox. It's a, simply classification problem. You can do text classification. You can do semantic segmentation. You can do labeling of 3D models. You can take a LiDAR model and do a point cloud labeling, which probably will take you hours to do per frame, but that option is there. So there's a lot of custom UI you can actually do as well. In the back end, you have access to public workforces. So my team actually uses this. So for labeling an LP workload. So there's a lot of people that you can hire. So that includes vendors that are specialized in labeling data sets. There's also folks that are, general public that they would be willing to do this for you. And of course, you can have your own private workforce. And back to the algorithms. So we support all of these built-in algorithms, and they're usually tested. And they don't change very often. That's good and bad, right? So for people who want to run production and want to make sure that their models are always working properly, having a slower moving first priority set of algorithms that they know always works and is always producing the right results for them, that is important to them. So these are the algorithms that are not going to change very much, and we're just going to offer that as a supported first-class algorithm, because a lot of open source tools, they change and something breaks, and then you kind of have to, you don't get much support usually, right? So this is actually supported directly by Amazon. And then I want to talk a little bit about the API. So how do you invoke training? So you basically wrap everything in an estimator. That's pretty much standard across the board on things like scikit-learn. So you built your estimator. The first thing you would do is to give it the hardware which you want to train this on. When you see ML, that means they're ML instances. And they're no different than the traditional EC2 instance. It's just that for us to distinguish what you actually used. So C4 is a compute intensive instance type. And there's of course the P instances, which means they're accelerated computing instances types. And you can give it how many you actually need. You can do distributed training if you want to use HoloVault. And then there's of course there's hyperparameters which you can set for SageMaker. And then finally, you can deploy and host that using the model.deploy API. So you can use a C4. If for GPU-ready instances, a G4 instance is more appropriate. We're going to be using a G4 instance today. So if you want to do distributed training, we do support SageMaker, Vault, or parameter servers. Parameter servers are very much default for MXNet, and Vault is more used for things like TensorFlow, if people want to do very large distributed training. So all of those are supported. Hyperparameter, we do actually have a HPO service. It's actually really easy to use. In fact, I'll send a link later in the training to show you how easy it is to be able to use use HPO and combine that with things like Rapids to to be able to do HPO parameter sweep very economically using our spot instance that's built into SageMaker. Yeah, so there are also two ways of deploying your models. There's batch inference, and then there's real-time on-demand inference. So the real-time on-demand inference is, basically what everyone uses, but if you want to use batch inferences, you can also call essentially SageMaker batch. So it will do that in a batch format so that you're not, you can do that even more efficiently. And then there's auto scaling, there's A/B testing built in, there's all of these different features that, at some point, some customers have requested this. So deploying that across availability zones allows you to have a good, DR. And if you want to be able to load multiple models onto the same instance type, like a V1, V2, or maybe other models, you can do that too. It's called the multi-model deployment. And then of course there's model monitoring among other tools. So a lot of these tools you can probably build yourself, but they are just more convenient to use when you have them integrated into one system. So this is more of a, I would say, cron job. So essentially on top of the hour, there's a little cron job that runs and that checks to see if there's a model drift or any other problems with your model, and then you can take action. And you can, like I said, you can certainly do everything on your own. It's just that here's an implementation of it. And you can at least look at the baseline of how things should work. SageMaker Neo is another tool which I think is very much magical. It's called it's based on the open source tool called TVM. So the idea is that it abstracts away the various hardware architectures and basically optimizes it for you underneath. That has worked really well for a lot of our customers. And what I found is that TVM can get up to, let me see, 6x speed up for certain type of models. So for MobileNet, I think we were trying that on MobileNet vision architecture, we were able to get a factor of 6x speed up just out of the box. So some of these work really well. Like for language models, it might even perform better than things like TRT, which is specific to NVIDIA's TensorRT. It's called model optimization, hardware optimization acceleration underneath. But of course, we do use TRT under the hood when it comes to optimizing for NVIDIA specifically. Yeah, so another thing I do want to highlight and talk a little bit more about is my current job. So my current job is to help developers and researchers to be able to take advantage of some of our innovations that's coming out of various labs we have on our, at my team. The first thing is DGL. So DGL stands for Deep Graph Library. So it also comes with domain-specific toolkits like the DGL Knowledge Graph DGL, Life Science, among other packages. And we've had some really good, I would say, improvements by applying graph neural networks to problems that you are working on just using plain, I would say, attention models or CNN models. So we've had somewhere between 10 to 20% improvements, and sometimes even more, when you apply graph neural networks to a problem that you commonly use. And this is an area of active research and active industry adoption. And certainly is something that you might want to look into if you are doing research. It's called dgl.ai is the URL. The Gluon TS is the time series work that we actually use at supply chain optimization among other teams. So we've recently had Gluon TS being used at the M5 competition, which is the famous time series competition. We were able to achieve number 2 without a lot of work on it. So there's definitely a lot of deep learning new research, deep learning based new research on time series data. So I would say Gluon TS is probably one of the most important packages when it comes to financial services and forecasting. And if you know how to use these packages properly, you've got your career made for the next 20 years. And forecasting is what everyone wants to do, and be able to do that accurately using deep learning models is particularly, I would say, useful. And then there's AutoML. So AutoML is something that we're trying to standardize. So that's my job. I'm trying to standardize AutoML or AutoGluon across Amazon. So for people who are not necessarily all that technical. So we are, we've had some really, really good luck so far. Unfortunately, I can't really talk too much about it because they're internal information. But I would say that's probably Amazon's best kept secret at the moment. It is completely open source. We're going to be releasing a new version in the coming months. And what it does is it does a multi-stack ensemble. So the idea is you're having a nonlinear combinations of all multiple different models. And we're able to achieve really good results and beating 99% of all the Kaggle competition out of the box. So all you have to do is to give it 3 lines of code. You load a CSV file. This is, AutoGluon tabular. And then you basically run the training, and you would be able to get Kaggle level accuracy. And this is, I would encourage you guys to join our Slack channel. And this is definitely things that we see a big future of. So currently, Gluon supports tabular data, but we are actively adding things like vision as well as natural language processing, essentially taking the embeddings of NLP and feeding that into it. And then, of course, there's the D2L book, which is a great machine learning book for you to get started on. That includes, I would say, probably the most detailed accounts of all the different theories and practices. And you can go to d2l.ai to access it. And the biggest selling point is that you have all of the notebooks built in both PyTorch, TensorFlow, as well as MXNet. Okay, so this is essentially a reference. You feel free to take a picture of it. And I would, at this point, I'll hand this over to Rachel. So Rachel, it's all yours.
So thank you, Wemi, again for introduction of the great AWS service. So now let's dive deep into more technical details of the NLP modeling. So here we have these 3 layers of general landscapes of performing an NLP task. So for most of the NLP tasks, it has those 3 layers. So the bottom is a pre-trained layer, and which we have those like word embedding inside. And then we move into the intermediate is the architecture layer, where we can fit in different neural network architecture, like the MLP, multi-layer perceptrons, or CNN, RN, which is convolution neural networks, and recurrent neural networks, or can fit just in those attention models, etc. And then moving to the top of the layers, you will see the different downstream applications of NLP, like the sentiment analysis, machine translations, question answering, etc. So those are the so there are like 20-ish those like NLP tasks that we can deal with, and there are a different data set for each of the tasks. So, and let's start with the pre-trained layers. So we classify the pre-trained layers to 2 types. The first are those like shallow word embedding or shallow word representations, which includes like the word to work or the glove and so on. And those embeddings will represent a word or characters or subword with a number of array, so a vector. And the number can be like 50 to like 300 dimensions. And another fold is the deep word representation, which involves bird and its family, like those GPT things that women just talking about. And so those birds embed a word or sentence or paragraph with a number of array with like 1,000 dimensions, which is much larger, but it can encode the whole sentence, the whole paragraph. So in the next following slide, we're going to dive into BERT. So you probably ask why BERT got so popular and so prevalent in like the past 3 years, even though like NLP has been there, like the whole area of NLP research has been there for like 10 or 20 years. So the traditional language modeling has problems. Well, so here's a problem. I remember there's like a few months after I joined Amazon, I saw those like news title, Amazon is on fire. And I was super confused at that point. I was like thinking, did they mean the Amazon like the forest or the Amazon the company? And for the on fire, it's even tricky. Does it mean like the building is on fire or the company itself is on fire, etc.? So as you can see, the natural language is super ambiguous, polysemous and anonymous. And sometimes in the spoken language, it's even worse because of those homophones or those prosodies, etc. So that's the issue that BERT is going to tackle. So BERT is short for bidirectional encoders representation from transformer. So as you can see from the name, it's bidirectional. So what does it mean? It means that when the model is going to look at a paragraph, it doesn't only look at from left to right, but it also looks from on the right to left. So from both directions. And is trained on a transformer encoder. So we are going to introduce transformer a little bit details later in the following slides. But remember, BERT is a transformer encoder. And BERT is a huge model, but it's not only focused on one task. So it's task agnostic. So you can fit BERT model with one extra layers on any NLP task, like NLI, MT, machine translation, sentiment analysis, question answering, etc. So you can just fit any task with one extra MLP layers or any other layers for your convenience. So that's BERT, and why it's so popular? Because when it's come out, it improved 11 NLP tasks to the most state-of-art result. So previously, before BERT came out, how the researcher working on those problems, they work on just one NLP task, and they try to fit that task with one specific models. So on those like 10-ish or 20-ish different NLP tasks, we have all different kinds of models. But when BERT came out, it's like a universal task anomalous models, and it outperform on a lot of different NLP tasks. So that's why we call it it's super powerful on those transfer learning skills. So as I just mentioned, BERT is coming from the transformer encoder. So here is the overall transformer architecture, and BERT was trained on the whole transformer, but when we use BERT, we are going to only extract the encoder part from the BERT model. So let's take a detailed look of the transformer. So before we talk about the architecture detail, we first need to understand why we need transformer. So if you are familiar with those CNN, the convolutional neural networks, or the RN, the recurrent neural networks, you probably know the pros and cons for the CNNs and RNs. So the CNNs are easy to be parallelized to train at the layers. However, it cannot capture the variable length or the sequential dependencies very well. So that's why CNN is more suitable for those image, object detection, image classification, object detection, etc. And then if you have been using RNN, you probably be aware that RNN is super great at capturing those variable length sequential information, especially this long short sentence. But it suffers from its inabilities to parallelize within a sequence. So that's the pros and cons for the CNNs and RNNs. So to combine the advantages of the parallel training from CNN and the sequential information abilities from RNNs. So when Simi et al. At 3 years ago, they invent those transformer architectures using the attention mechanisms. So it achieves the parallelization by capturing those recurrence sequence within the multi attention models, and at the same time, it encodes the position of the sequence by this positional encoders. So as a result, the transformer leads to already compatible models with a significant shorter training times. So let's take a look of the details of transformer. So here is the overall transformer with this decoder, encoder and decoder architecture. So as you can see, the source, so for example, if we have a machine translation task, and the source will be a source language, for example, English coming in. So this embedding, this positional encoding, and then it will move into this transformer encoder blocks, and then be transferred to the transformer decoder blocks. And at the same time, the target language, for example, like French, will be then fitted into this embedding, to the French embedding, and then fitted into this transformer decoder. So that's the whole overall architecture. As you can see, it's an encoder-decoder architecture. So that's a basic idea. Compared with the traditional encoder to decoder, especially those sequence-to-sequence language model, you'll find like this transformer connect each of those encoder blocks to each of those decoder block. So we probably have like 12 transformer block. As you can see, there's n times here, so this n can be 12. And each of this encoder block is going to connect with the decoder block on the rest. It can be another 12 decoder block. And another fun thing, why we call it transformer, is like super huge, and it really looks like a transformer. So let's take a detailed look of the transformer block and the positional encoding. So that's the two most important part of the transformer model. So let's first take a look of the positional encoding first. So how does the transformer trying to record each token's position in a coming sequence of paragraph or sentence. So since the self-attention layers or anything inside of this transformer block doesn't really distinguish the atom's orders in a sequence, so this positional encoders is trying to encode the layer and is used to add the sequential informations with this sine and cosine functions. So for any tokens coming in, it has its ranks in the sequence, and we're just using the sine and cosine functions to encode their positions. So that's the basic fundamental logics for positional encoding. And then moving to the transformer block, it has three kind of functionalities. So the transformer block of the transformer encoder, it contains the multi-head attention, as you see over here, and a positional-wise feed-forward network, or FFN. With like two layers, we can, if you use the 1x1 CNN before, so basically these are just like the 1x1 CNN tries to apply some transformation on the existing feature to some new features. And in between of this positional FFN and multi-head attention, there are this add and norm. As you can see, there are two add and norm. So basically, those add and norms that contains residual structures, like those resonate, like you can add it in, but also apply the linear normalizations to apply all this normalizations over all this feature over the same layer. So that's the linear normalization. So that's like the three fundamentals of the transformer block. And then we have been talking about the most meat part of the transformer block. Let's take a look at how BERT was trained, especially from the embedding side. So for BERT model, we are going to input a sequence in from the embedding. And the embedding actually have three parts. As you can see, at the top part, we have this token embedding, which embeds each tokens into a vectors, which includes the tokens from the COS, which stands for, it will be a classification task. Or if you can put another task over here to let BERT know what kind of task is it, because it's trained on the agnostic, on the task agnostic on different NLP downstream tasks. And then we also have this separate tokens, which to separate two sequence. And then moving to the next layer, we have this segment embedding layers, which works to distinguish a pair of sentence with this embedding A and embedding B for these two sequence. And moving to the bottom, we also have this positional embedding. As I just mentioned, is to embed what position does each token locate on each of the income sequence. So in this example, it's like from 0 to 9, we're going to apply some sine and cosine functions to transform to some sine cosine curve positional information. So that's the embedding part. And after the transformer blocks, positional encoding, the embedding, that's the whole overall of this transformer encoder of BERT. And similarly, the transformer decoder works similar as the encoder, and I won't be too verbose here. And if you're really interested to the technical details of how do we implement BERT, how do we pre-train BERT, you can check out on DTL or dive into deep learning to say how do we pre-train BERT, how do we build each of the sections from scratch using just Python or Glue from scratch. So that's BERT. And today we're going to focus really on how to use a pre-trained BERT model. So you probably wonder how BERT was pre-trained. Actually, it was only used like it was pre-trained on a large, like 3 billion data set, and it used like this next sentence prediction as a task to predict whether two sentences are connected with each other. And it also used some MLM, which is mask linear modeling, to try to predict, oh, I'm going to mask some words or some tokens in a given sequence, and then my BERT model is going to predict what the mask token will be by this bidirectional encoders. So that's how it's pre-trained. And actually, in this session, we're going to focus on the fine-tuning, especially at our lab. We're going to focus on how to fine-tune on those NLP tasks. So basically, how do we fine-tune it towards our different tasks? And the first thing we are going to do is we are going to add an output layers. It can be a dense layer, which is also called the MLP, the multi-layer perception layers, which is just a bunch of neurons. If you're going to have this classification task, if you're going to have like a binary classification, you probably need 1 or 2 neurons. If you're going to have like a multi-class classification, you're going to have multiple neurons, etc. And if you're going to have, like, for example, we're going to talking about the QA task or the question answering task. So basically what we're going to do is we're going to predict which will be the start position in our given context and which will be the end position in our given context for our answers. So basically our answer will be extracted from our context, and we just need to predict whether it's a start position or whether it's an end positions. So that's a basic idea for fine-tuning. It just like to use the pre-trained models, use the pre-trained parameter weights, which are pre-trained on those Wikipedias or those books, and already have some knowledge or contextual knowledge, and can be applied on most of our daily work. So that's what we're going to focus on today, the fine-tuning. And a little bit side story of BERT. So that just a little that BERT got so popular and so prevalent after it's coming out for the past 2 or 3 years. So basically, BERT is belong to the semi-supervised sequence pre-training NLP models. So it's a transformer-based model, and it raises a lot of attention. So no matter for ALMO or GPTs or BERT or just like XLNet, and those models are all coming out actually around those like 2017 to 2018-ish. So the BERT paper is actually published late 2 years ago, late 2018, which brought a huge enthusiasm in research. And after the BERT paper, actually, research really also derived this whole family of this BERT as like this. We first have this BERT, and then researcher just gather like 10 times larger data set and trains at a longer time with like 4 to 5 times longer on those TPUs to train those RoBERT, which also called robust training of the BERT, because training of those BERT are using the distributed training and super easy to get diverge. And we also have like those knowledge BERT, which are the BERT trained on the knowledge graph. And besides, we also have those GPT families. So rather than like the BERT, which is a transformer encoder, the GPT family is actually a transformer decoder blocks. So what does it mean? It can generate any language. So it can read the novels. It can generate text summarizations. Rather than like BERT, it can only do some classification tasks by adding 1 extra layers that based on your text. The GPT, no matter 1, 2, 3, it can just generate anything as long as you talk about, as long as you give it some context. It can give them a prefix. It can give it like a sentence and let it to write the whole novel itself. So that's like the pretty cool. So this is actually the GPT-3 or 1, 2, 3 of the transformer XL or those XLNet are actually those autoregressive model. So basically the fundamental statistics are those autoregressive models, where BERT is kind of autoencoder models. So that's a major difference between the BERT family and those like GPT autoregressive model family. And that's the semi-supervised pre-trained tasks. And as I just alluded, we're going to focus on the question and answering test today after we understand a bit of the bird and those transformers. So what does question answering talks about? What are the input and output for the question answering? So for question answering, we have two pieces of text as input. So one piece is a question, for example, who shall use D2L? And another piece is a whole paragraph of passage. We call it context. So this context is coming in, and our model is trying to figure out and trying to extract a partial of the phrases or words tokens from our context to try to answer our question. So as you can see, the context dive into deep learning or D2L as an interactive open source deep learning online book with the code, with the math, with discussion, and it's designed for the engineer, researcher, and students to learn state-of-art NLP with in-depth theory and fast prototype notebooks, blah, blah. So as you can see, after you see this engineer, researcher, students, probably this is the answer to this question. And our models is trying to output the tokens positions inside this context. And in the end, we're just going to, based on those token positions, to find which are the tokens from our text to output our answers for our given questions. So that's the task we're trying to deal with today, and we're trying to build and fine-tune our BERT model for the question answering tasks. And then I will just introduce the D2L a little bit more so basically D2L is kind of open source textbook, and it has been adopted by a lot of universities around the world. So like more than 140 universities have been used our book as textbook. And besides, we also taught a class at Berkeley last year. So all the slides, all the videos, all the different projects by the students and were out there on this website. And I was also the TA for this class back as a graduate student at Berkeley. And our VP at Smola, who was a full professor at SMU, also teach the class at Berkeley. So all the videos are online if you would love to learn more about deep learning. I need to charge. Never mind. And so what do we cover on this box? So we talk a lot about theory, the fundamental statistics, the optimizations, or the how to use the GPU to do the parallel training. And we also have the 150 different random notebooks. So they're all Jupyter notebooks. You can just clone on our GitHub and just run it on your own machines to learn deep learning by coding. So that's the most fundamental way to learn, especially for me. I feel like if I just read a book or read any papers, it doesn't help me learn. Only if I code it myself, I feel like I can learn faster. I can really dissolve this information, dissolve this knowledge inside of my brain. And we also have multilingual, so we have our Chinese version and our English version, besides like the Turkey version, the Japanese version, the Korean version, the French version are all under development. So DeFi also have been adopted from NVIDIA, like Jason Huang, who is the president and CEO of NVIDIA, also said like it's an excellent book. And I won't just do too much advertising, but save time for our lab. And also it's mobile friendly, and you can also download the PDF and can run it on your local. So that's it for D2L. And now let's dive into our lab. So please click this event box engines, and Wenming will walk you through how to launch this event engines within this link and how to install our today's notebooks from our GitHub website. And so Wenming, I will hand out back to you. If you're talking, you're muted.
Yeah. So let me get back on video here. Well, first of all, I want to thank everybody for coming, and this is the real part of the lab. So we're actually going to be doing the lab. I can see that there's a lot of people that are already logged in. So the link is in the Zoom window, so you'll be able to click on it and be able to join the lab, and I'll walk everybody through. So let me try to share my screen. So Rachel, would you be able to?
Yeah, I just made you as host.
Yeah. Okay, great. Thank you.
So you can just steal my screen.
Okay, thank you. Yeah. All right, let me actually see if I can share it's a little recursive. I'm sharing the screen of the screen. Um, let's see. Let's see, can I actually, that's right. So first of all, for those of you who are not familiar with AWS, yeah, definitely, put your question. There's no such a thing as a stupid question, so feel free to ask them in the room. So what I will do is walk you through the process. So first of all, you have gotten a little link at the in the chat room. So I'm gonna actually use the same link as everyone else and walk everybody through. So let me open a new tab here and put in this link. So this is something called Events Engine, and what's really cool about it is that we can, without an account, you don't need to get an account or anything. So we basically create a temporary account for you. So there's a little hash there, as you can see. And once you're logged in, you will be able to go to the AWS console window. Okay, so that would allow you to open the AWS console itself. We're going to be working on the US East 1 region. There's a lot of different regions for AWS. So US East is one of them. And it looks like I need to basically do this again because I was logged in previously. So there's US West, there's US East, so those are the major ones, and there's one in in Europe. There's lots of different regions, and you should pick one that's appropriate for you. But in this case, everyone is going to be on the East Coast. Once you're logged in, the first thing you might want to do is to find SageMaker. So for me, SageMaker just showed up, but if you don't see it, you can just type SageMaker. It will show up and you can double click on it or single click on it once it shows up. So I just logged into SageMaker. This is the SageMaker console. So the first thing you want to do, you might want to go a little slower here. There's also, so Rachel, can you paste the instruction to the Chime room? So not Chime room, I mean Zoom room, from the README file of the instructions. So you can either follow me here, or you can look at the link that Rachel has pasted in the Zoom room. So either way works. So the first thing I would do here is to go to the notebook instances. So of course, I kind of talk a little bit through SageMaker. There's SageMaker Studio, there's the dashboards, and there's ground truth lets you do labeling jobs and complex labeling jobs. There's processing jobs, there's training, there's inference, there's marketplace, there's augmented AI. I mean, there's all this stuff that you can do, but let's start from the beginning, which is to create a notebook instance. So I'm going to create a notebook instance. First of all, put in a name. So you might want to, pick a unique name. So I'm going to say Toronto Machine Learning Summit Wenming, what you call it, the live notebook. And the different type of instances, you can do all kinds of different things with them. So MLT2, those are kind of burstable little instances. And they are very inexpensive. Then of course there's the T3s, they're the newest burstable instances, meaning that if you have noisy neighbors or if you have non-noisy neighbors, you can actually kind of burst. You can use more resources than your bounding box offers you. So M5 stands for memory. They tend to have more memory to processor ratio. And then there's compute optimized, which is C5. And the C5s and C4 is the last generation. So I'm going to pick a C5 4 extra large. That will give you 32 gigabytes of RAM. And that's actually quite a bit. That's quite a bit of RAM. So additional configurations under here, you might want to change that to 50. So I want to make that into 50 gigabyte. Don't forget to do that because you may run out of space. So once you've done that, you want to go to the GitHub link. And the GitHub link is essentially what the README file has given you the instructions on. Okay, so let me actually find the link myself. Let's see, where is it? Yeah, the TLMS link. So you want to copy this link and put it inside the GitHub repo. So the idea is that you would be able to immediately launch it. So just want to make sure that everyone has this link. Rachel, can you please put this link in the room, please? So that everyone has it. Okay. So once you have done all of the above, let's actually review what we put in here. So you need a name, you need an instance type, and you need 50 gigabytes. So under additional configurations, you need 50 gigabyte for the EBS volume. EBS volumes are essentially a remote drive that's attached to your instance, which means when your instance gets shut down, that EBS volume is still around, right? So
sorry, Winnie. Sorry, just a quick show. Can you make your Chrome full screen? So for
yes, yeah,
everyone's easier to.
Yeah, okay, got it. Can you guys see it well? Better now?
Yeah, it's
Did I
much
make
better.
it
Thank you.
bigger? Okay, great. Okay, so and then if I go down, I basically set the GitHub repo to clone a GitHub repo to the notebook instance only, and I gave this link. So I'm gonna hit create notebook, and hopefully it's gonna work. Not hopefully, it should just work. And one of the I would say things that I can, there's a lot of uncertainties in life, but there's one thing that I always found to be reliable, which is EC2. So I've been doing these type of training for 4 years, and EC2 never fails me. And that's one thing I can rely on in my life, which is EC2. It's always going to be running. And TLMS, so once I click on it, it will kind of tell you it's provisioning, it's pending. So this is going to take you a few minutes. And in the meantime, we just relax and wait. It should take you about 5 minutes or less. So any questions at this point? You feel free to unmute yourself and ask me a question.
Hey, yes, I have a question.
Yes, please.
So, on this AWS, what I've understood so far is we created a notebook. We gave an instance type based on the requirements. But can you please repeat again, why did we link it with a GitHub repo? I mean, what is the purpose around it?
Oh, so linking to the GitHub repo is that when your instance starts, it does the git clone action for you. So you don't have to go in there and do it manually, but I also show you how to do this manually. Does that make sense? So essentially it's just, kind of streamlining the creation of your notebook instance with the GitHub cloned for you when it's up and running. Does that make sense?
Okay, so basically this notebook would be a part of the Git repo, the defined Git repo. That's what I understand.
That's correct. It just clones a copy of it. You can clone pretty much anything you want. Yeah. If you don't do it, it's just empty. And you basically have to go into Jupyter and say, I want a terminal, and I say git clone. It's the same thing. So this is just for convenience purposes.
Okay, thanks.
Yeah. Okay, so I hope everyone is at least gotten that part started. So mine still says pending. It's going to take a few minutes to run. Of course, there's other instance types. There's, if you go search for this on, Google, you would be able to find, yeah, so you'll be able to find SageMaker pricing, and you'll find all the different instance types. So there's on-demand notebook instances, there's processing, there's SageMaker Studio. So there's like how much they cost and how big they are. So M5, as you can see, M5 extra large will give you basically 4 virtual CPUs and 16 gig. What we picked is a 8 vGPU, CPU, and 16 gigabytes of RAM. Okay, so this is only for the notebook instance. For the training instances, we spin up additional instances to do the training. So this is not where you actually do the training. So just for your information. Okay. All right. So how are we doing on spinning up the instance?
I have a question. How
Yes,
did you
please.
decide on the size? Like, so how can you?
That's a good question. So how do you decide? The best way to decide is to think about how big your notebook is for pre-processing. So if you're going to do some pre-processing before you send it to the training job, as long as they can actually do the job. So for example, here we're actually creating a machine image. We're creating a container. So that can be IO and memory intensive. So I decided to pick a C5, but you can certainly pick a smaller instance like a T3, which will probably do just fine. It's mostly memory bound. That's the way I would pick it. If you have a bunch of GPU job, you might want to pick like a P2 or P3 instances if you want to run any kind of GPU. It just depends on the work that you're running. So mine is actually ready to go. So I just simply opened up the Jupyter, but you can also open Jupyter Lab. I mean, however you want to do it, it doesn't really matter.
I have a question related to the instance size. So does it also matter how much data we are going to process with this model when we are deciding the instance size?
Yeah, so how much data, like usually you want to keep your data in an S3 bucket. So that doesn't matter as much. Your hard drive that's attached to that particular instance, there are 2 things that matter. One is that the EBS volume, which is part of the machine. So when you go to the machine, it will tell you how much space there are. So that matters. And the second thing matters is your IO. So certain types of instance give you more IO bandwidth than others. So just take a look at that, and that will help you to pick the right instance. So for example, the C5, it not only actually this doesn't actually say here, but it will give you like a maximum bandwidth if you look at the EC2 page. But here, if you look at the P3, so it gives you a CPU, and it also gives you 1 GPU. And the rest of it is like memory intensive. So for example, if I were to do stuff that are, like a tree-based models or anything like that requires a lot of memory, I might pick these, C5 or maybe M5. So as you can see, the M5s actually give you a lot more memory. So hopefully that answers your question. So it has to do with the amount of memory you have, the amount of processing you want, just in the notebook instance. But if you want to do training, offload the training, that's different. So that's an entirely separate cluster that you're spinning up. All right, so for notebook, mostly you're just doing simple processing and simple stuff there. All right, so let's go back to where we were. Okay, so I did open this notebook, right? So you want to go to BERT fine tuning and open the BERT PyTorch fine-tuning QA IPython notebook. So you want to open that up. So it should load for you relatively quickly. So for me, it's taking a little bit of time. on a C5 instance. But normally it should work instantly because the instance you created, which is a C5 instance, has 32 gigabytes of RAM. That's actually a pretty beefy machine. Okay. All right. So let's walk through this a little bit. And the first thing I want to show you, for those of you who are not familiar with Jupyter, so Jupyter allows you to basically do interactive computing. So interactive computing means that you are interacting with this notebook by stepping through the different cells and look at what each of these steps actually can do. You can stop the process, you can fast forward, you can clear out your kernels, you can look at it from different modes. You can do visualization. So Jupyter Notebook was originally called IPython. That was essentially written by 2 graduate students that happens to sit next to me. And from the physics labs of University of Colorado. So that later became Jupyter. So they are Brian Granger and Fernando Perez. So those are the 2 guys that invented Jupyter. So originally, this was intended not for machine learning, but rather for physics simulations. So there were kind of like MATLAB-like, activities. So machine learning, turned out to be requiring this type of interactive computing user experience. So that's why everyone is now using Jupyter. So here's what we're going to do. So as Rachel said, this is a BERT model, and we're using PyTorch here. And we're doing a question and answering using the squad data set. And this is fine tuning. This is not training it from scratch. If you were to train BERT from scratch, it's going to cost you $10,000 or maybe a little bit more. And if you were to train things like GPT-3 from scratch, it's going to cost you $5 million. So most people won't be doing any type of training from scratch unless you are in an institution that has a lot of resources available to you. Okay, so and then there's NGC is the container that came from NVIDIA called the NVIDIA GPU container. Or so essentially we are basing everything on this container. So let's actually step through this process. So the first thing is to do is do a shift enter. That means you're running through each of these cells. So the next step is that we're including BOTO, BOTO3. So that's a SDK for Amazon. So if you want to access S3 among other things, you'll definitely be needing that. And of course, we included PyTorch. As you can see, there's all the PyTorch stuff that we included. We also included the SageMaker API. So you can see the SageMaker estimator, among other things. So you can read more about it on the SageMaker website. There's a lot of detailed documentation around it. And then the next thing we want to do is we want to start a SageMaker session. And we're going to do a default bucket. This is just mostly for your convenience. So the default bucket is an S3 bucket that you put all your stuff in there. So instead of creating one manually, it kind of provides one for you. So we're basically saying this is where everything is. So the next step is, I think I already ran number 1 here. And then the next step is that we want to download that container. So that container is somewhere on NVIDIA's website. And what we're going to be doing is to add a bunch of stuff to it. So like we're adding the SageMaker SDK, among other things, and creating a directory structure where it's ready for training, as well as hosting. So there's a bunch of stuff that we copy over, and you can read that in details. And we're going to be creating a Docker container here. So as you can see, that the first thing we did is to give it a name for an algorithm. We're using something called ECS, or Elastic Container Service, which is a lot easier than things like Kubernetes. So it removes a lot of levels of complexity, or essentially abstracts away a lot of complexity when it comes to containers. So you're going to create a container and essentially use the service to take the container that you created and upload it and register it on ECS and upload it there. So the idea is that you can then use this by the training cluster and as well as by the hosting cluster. Okay. Next step is that we're going to be setting up all of this in ECS. Basically, you set up a region and you create an account and you put everything there. Before we actually upload and build the Docker container, we need to set the permissions. And the permissions are set. So you want to run to this line, which is role equals SageMaker.execution role, and actually open up the ECR permission page. So I'm going to do this now. The first thing I'm going to do is I'm going to copy everything between these two brackets. I'm going to do a copy of it and then go into access this link. So Rachel, if you see any questions, please let me know. So then you click on edit policy JSON and you basically copy everything here. But before you save anything, you want to make sure that you wait until that the notebook actually finishes running up to this point, where it actually shows you what the SageMaker execution role is. And that's going to take maybe a few minutes for it to do. So as you kind of look through the running, it's creating, it's going to take a little bit of time for everything to register and start. So any questions so far? You feel free to unmute yourself and ask me a question. So far what we've done is we've created an account on ECR or Elastic Container Registry, and we're going to be registering this particular image. And we've also done some of the we've gotten the base image from NVIDIA. We're trying to create a custom one and then upload it onto ECR. So that's what we're doing so far. And before doing that, we do need a permission to set the permission properly. Okay, so where everybody is pretty much waiting for this role equals SageMaker get execution role to execute. But if you don't do that, you're not going to have permission to be able to upload everything to the ECR. Okay. So let's just wait. Any questions?
This is the permission to get the things into SageMaker or permission to get
into
things
ECR.
out of SageMaker? Okay, I see.
Into ECR. So you created I mean, you can do this, you can build this Docker image anywhere you want. You can create a EC2 instance and create it there. It's just more of a, we're just, giving you the convenience of creating that inside the notebook. So I already got this output, as you can see. So for those of you who just started paying attention to this, so you want to copy this piece, the first piece and the second piece into the ECR access link. So here's what I will do. I will copy the first, everything between these two brackets and go to the ECR page. And then I want to edit the policy JSON and replace what's already there. So as you can see, I did this. And then the next step is you want to copy everything inside the output of line 7 and then copy it in here, replacing the line that says XXXX. So I'm putting that in and I'm going to hit save. Okay, so once you hit save, it's going to have a bunch of other stuff in here. So I think it saved it. And if you scroll down to the bottom, I think it already saved everything. Looks good. It may show you actually another page that you may have to save, twice. But I think it's already saved.
Could you please ping the ARN of the role because it's not coming up?
Sorry, say that again.
Could you ping the ARN of the role, execution role?
Oh yeah, so let me see. So don't copy mine. So you should have yours. Yeah.
Okay.
So it's this one. So it's the output of line number 7. So basically what you're doing is you're giving it a permission for ECR to register. And then this is the policy statement in JSON, and then you want to actually make sure you have your actual role to grant the permission inside the statement. So that should work now. So if you edit this again, so for some reason mine didn't really save properly. So I'm gonna, oops. Yeah, don't worry, we have plenty of time. So I'm gonna do this again, basically go into this statement and I'm gonna say, paste it here. And then basically, you have to paste it twice, right? So copy this row and go back to the statement and put this in the team row. And you want to hit save. Yeah, so I think it saved it properly this time around. Okay, so we're good here. So once we've saved it, we want to go back to the the notebook. So we're going to build the Docker now. So as you can see that we're pushing the Docker. We're doing a docker.push. And this is going to take a little bit of time. So docker.push pushes the what you've already customized and into the system. Yeah, so here you are doing the docker.build. That all happens locally. Yeah. So the purpose of doing this is that we have essentially created a custom Docker that we want to push to the registry so that when we create a cluster to do training, it has the Docker, it gets the Docker Docker image that we created to do custom training. So does that work? Everyone's good on that? Okay, so we did push that in. So so time for pushing Docker took about 45 minutes or so.
What is it about the Docker container that's customized, just so we understand? Like, why couldn't you just use an off-the-shelf container? Is it the permissions or?
Yeah, so there's specific machine learning. Yeah, there's a couple of things. One is that we're using this particular image that has PyTorch, the latest PyTorch image in there. It has all the drivers and proper stuff. And then we also have this machine learning directory, which we created, which we're not going to go into too much details here. But there is a directory structure which you need to do. So for training, as well as for getting the right right inference models that we're copying certain type of directory structure and SDK into this particular container. And we can look at the Python file in a bit after we start the training. Yeah, so there is stuff that you are actually doing with this. It's just not being shown in this page. There's a function that we call to build this specialized container. Okay, I'll go into a bit more details in a bit. So is everyone good in terms of that piece? So the next piece we want to do is to start the training process. So the first thing you want to do is to set the hyperparameters. So the hyperparameters are essentially the parameters which you want to set for the particular model. As you can see, there's workspace, BERT, and then there's opt, ML, model. There's the training. There's all this extra stuff that you are actually adding. Of course, there's the model batch size. So we're doing 1 epochs. We're using 4 GPUs. We're going to do 1 epoch training. Maximum length, that's the default, is 512. And then there's the document stride, which is 128. And then there's a seeding, there's a learning rate, and you have a default bucket. So once we've done that, we're going to essentially start the training process. Okay, so the training process starts by defining what the estimator looks like. So the estimator looks like we want to have one instance, but this is the P3 8 extra large. What that means is that you're creating you're using a machine with 4 GPUs on it. And we are using PyTorch version 1.4. And then we want to start the training process there. So, as soon as you call torch.fit, it will start the training job. So in essence, what you've done so far is you've created a special Docker image with all the appropriate files copied into the directory which this particular model understands, like the workspace BERT models, the JSON configuration, ML model, where the model would actually be written to once it's done, where's the training data files, among other things. And you've told it, how many GPUs you want to use for this particular training, how many times you want to run the training, and of course all the rest of the hyperparameter. And you've given it, you've instantiated the actual hardware, which is one P3 4 extra large, and you've started the training process. All right, so I hope everybody has gotten to this point. Yes, you have a question.
I have a question. Fine tuning, does this mean that we are training on top of the existing BERT model for a specific kind of task?
Correct. That is exactly right. So the way you think about it is that you have the base BERT model. And what you do is, I can hear my own echo in the background. That's why I kind of paused for a second. So there's multiple different type of downstream tasks that you can fine tune BERT model. So the idea is that you can give it the ability to do classification. You can give it the ability to do Q&A. So think about, you're really just chopping off the last a few layers, and you're adding that to the main BERT model to do the fine tuning. And you can give it, you can think of it as different adapters. Like I have a power adapter that has different tips. You can think of it that way. So you're not retraining the BERT model. You're simply, training the adapter part of it. So that's what fine tuning is able to achieve for you. Yeah, think about it this way. The BERT model is able to capture the language model, but the last few layers is, the downstream tasks are essentially doing what you're asking it to do by adapting to the tasks and data set that you give it. So fine tuning is really very efficient. So you don't have to train it for hundreds of epochs. You basically train it for about typically 5 epochs, 4 to 5 epochs with the downstream task data. So we can go into a bit more details in a bit. So what I want everyone to be able to do at this point is to run torch.fit. You should be able to see that the training job has started and has created a virtual machine. It's downloading the input data, and now it's downloading the training image as a Docker image that you've gotten.
How can you how can you look at the fit as it's coming around and decide if you want to terminate early?
You can look at you can stop this. I mean, you can essentially stop this, but typically for people that want to do this, you probably have a Python script somewhere that you would just add a line saying if certain accuracy, it depends on what you actually want. You can do training accuracy, testing accuracy. To a certain point, you can stop the training. But typically, I just train it for 4 to 5 epochs. And that's pretty much the default. It will get you to a pretty good state in terms of accuracy. So it's usually, if it doesn't get there, there's usually something wrong. You might want to go fiddle with your learning rate a little bit. But typically, fine tuning it's for BERT, it's about 4 to 5 epochs.
Thank you.
Yeah, I mean, that's kind of just the default that I use. I mean, I don't usually think about it even. Yeah, so it will get you to be very good, to be a pretty good accuracy by then. And of course, you can look at your, your accuracy if that's converging. But usually that's what everyone does. You just do that. Another tip is that when you're doing these type of training, you definitely want to try to use things like SageMaker, which it turns things off for you automatically. So typically, people kind of, the training typically takes more than 20 minutes, which is our attention span, to babysit these type of training. So you usually walk away, you go do something else. If you were to do this on EC2, make sure you turn off your instances. And that's probably the #1 thing we run into working with people, which is they forget to turn their instances off. And this is going to cost you quite a bit of money. So for 4 instances of GPUs, you're looking at $20, not $20, like $15, $12, I think. $12, $15, and you leave that running for a month, that's going to start costing you money. So SageMaker turns it off for you automatically when it finishes running. So that's why we recommend SageMaker to most people. But there's still people that prefer to use EC2 to do the training, like AWS batch, among other things. So as you can see, it's downloading. It downloaded all the data set, and it's starting the training. So I'm only doing 1 epoch. Yes, you have a question.
Yeah, first a stupid question. What really happens if you forget to stop training? Do you really have to pay the money? Sorry,
say that again.
What happens if you really forget to stop the training instance? Do you really have to pay all that money?
If you're using EC2 directly, you are obligated to pay for it. But I'm sure Amazon, when you call their technical support, when you call our technical support, those guys are pretty nice. But you probably the courtesy is probably once or twice. They won't just say, oh yeah, I forgot training again for the 30th time. So they probably won't be as willing to listen.
Of course. And my second question was the fine-tuning thing that we are doing, is it the same as transfer learning or is it something else?
So there is a little bit of caveat between transfer learning versus fine-tuning. So typically fine-tuning is, let me go close the door because my kids are all screaming and trying to get in. So bye, Alex. I'm in a meeting. Yeah, sorry about that. Unless you guys want to see my kids. Yeah, so fine-tuning does a little bit less than transfer learning is the way you can typically think about it. So transfer learning may be doing a little bit more. It may even affect the original model a little bit sometimes. But I don't want to, put a firm definition on these things. It really depends on what people are actually doing. But typically, there's a lot of different tricks that people do. So for example, when they do transfer learning, they might even freeze the main model. Like for example, the vision model, they might freeze it. TensorFlow, you can actually freeze these models and then say, oh, I want to train this part first. And then if it's not getting me the kind of accuracy, I might actually unfreeze the whole network and actually train the whole network again. So there's different things that different people do, and there's different definitions. But strictly speaking, for these BERT models, you are only tuning the piece that is, attached to the main model. Okay, so how's everybody doing? So I assume that everyone is able to see this training kind of going. For those of you who are interested in more details, and you can certainly go back to, this and look at the various, Python files. So there's, run squad, there's all these different things that we actually copy into the, what would we call it, the main container. Feel free to take a look at a lot of these files that if you're interested in looking at the details. Run squad is.
Yeah, exactly. So if you are not familiar with Squad, you can just take a look of that Squad demo file. It will help you to walk you through what does the data set looks like and how do we architecture our model. If you're really interested in do that much.
Yeah.
And that should be super quick since we're just going to do a little bit of massage on the data set, and that won't take you a long time as training. So while you're training, you can just look around and see how do we process this data set through the Squad demo Jupyter Notebook.
Yeah, and if you have any questions, you can feel free to ask us. But none of these things are like, one thing I want to set the expectations right. You're not going to be learning about, NLP in 2.5 hours. You're going to get a feel of what it looks like, and you're going to take a look at the slides. Am I still maximized on my? Uh-oh, there you go. You're not going to necessarily have time to, go through all the details, but it provides you an opportunity to be able to look at everything at your leisure. And if you are, new to this, and we suggest that you take a look at our, D2L book. So I just put d2l.ai there. If you want to learn more about attention mechanisms, that's the first thing you want to start taking a look at. So that's the attention mechanisms and how it works. Did I click on the wrong thing here? There you go. Sorry. Where is attention? Yeah, there you go. Attention. There's a famous paper called "Attention is All You Need." So that kind of explains what transformers are, and what's essentially sequence to sequence with attention mechanisms. And specifically, BERT is very much famous for multi-head attention. So you can't really explain it, but these multi-head attention has a mechanism of which it pays attention to various parts of your language or your data sequence. So for example, maybe it's paying attention to your specific patterns of how the punctuation is laid out. Maybe it's paying attention to grammar, parts of grammar, but it's not necessarily the specifics, but the multi-head attention basically pays attention to different features that is dominant out of our language models. But of course, it's also language dependent as well. But deep neural nets are able to see that. It's looking at the relationship between the words and its context, as Rachel explained earlier. And I think we do have, natural language processing, applications, all these other things that if you're interested in. So the piece that I'm actually looking for is, let's see, modern, that's right. Yeah, so this is actually optimization. So let me see if I can find more specifics of the language. There you go. So natural language application. So as you can see, these are all the downstream tasks that you're doing. So sentiment analysis, probably like the #1 thing that people love to do when it comes to using these BERT models. So I probably had like at least 20 or 30 different people asking me how to, do sentiment analysis. There are people applying this to their Twitter feed, among other things. So they're, fairly accurate. And then there's other downstream tasks like using, let's see, natural language processing. There's there you go. So there's, their language inference using attention, and then this is the chapter which you can look at, the model. Text tagging, Q&A. So this is all the downstream tasks that you can, additional downstream tasks you can look at. But so for this particular one, what I was going to show you is the squad. And as you can see, there's the BERT model, right? There's your BERT model. And then there's the labeling, that we provide. And basically you're fine tuning, this piece of it. And you can, certainly read a lot of this on your own. And of course, this data set, certainly, take a look at this data set. So they're all essentially labeled for this particular task. But someone has to label them, right? So if you want to just say, build like a dialogue type of Q&A, so the labeling is actually, quite a bit of work. So it's not, so as Rachel was saying, this is semi-supervised learning. So there's labeling that you need to do for the final part of it. So for Q&A to work really, really well, you would have to have some labels for your, final application. If you're going to do Q&A for your own application, data set. That's what I meant to say. So how's everyone in terms of the training process? Are we able to get to?
Sorry, I have two questions, Wei-Ming.
Yes, please.
Rachel. As I'm examining the training process, I see that you just also mentioned the run squad.py. Where does the script like calls that run squad.py? Because in your script it's just, so in your parameters it's transformation, right? Transformation.py. Where does it call that run squad? So I only see point is transformation.py and when
transform.script.
Yeah, sorry, transform._script.
Yeah, we can look through that. Yeah. So I actually haven't looked at this for a while. Let's look. Yeah. So there's so this is the transform script, right? So let me see where it actually calls. There you go. So this is the script which we looked at. So where is it actually calling? I have to find it.
Yeah, sorry, I didn't mean to really go into that detail of this.
No, it's okay.
Training process, but if we have time, I just went quickly look into, and I see that file is in the comment.
Yeah, so let me see where it calls the run.
For me, it's on line 785.
Yeah, it's a very big file, as you can see. I'm still looking through it. So you're on 11700, but I'm still at line 300. So I'm trying to find it myself. Let's see.
Line 785 is a comment, right? Is that?
Yeah, so yeah, there's a comment there, but let's actually see if I can find it. Yeah, so this is the pre-process. Let me see if I can find it. Yeah, another way to do this is you can drop down to a terminal. Okay, let me just go back. if I can move this over. So how's everyone's training process? Is it still going, or is it finished at this point?
Mine's is
Still going.
Still going. Okay. Yeah, so that's fine. So let's see. So I'm at Jupyter. So for those of you who are not familiar with this, you can actually open a terminal window on Jupyter, right? So in the SageMaker configuration, everything is actually in sample notebooks. So there's a lot of stuff in sample notebooks that you can copy and clone yourself. And then you can go to SageMaker, which is what you cloned your TMLS 2020. So let's just go into this directory. So let's do this. Find. You guys called it run squad, right? Let's see, actually, let me just grab this and. So you can see that it's in modeling.py in here, and also the transform script is somewhere in here. So that you can look at the specifics of where this might be executing. So let's look at that. So there's modeling, and then there's the transform script. Okay, so look, let me go back to this and see if we're finishing running. So the model that I just ran actually did finish training. So for those of you who are starting to see that it's uploading generated training model, feel free to take a break for 10 minutes, and then we will be back. And then the next step, what you're going to be doing is to run the deployment. We'll run through this when folks are back. So the deployment, what I want to do is that for those of you who are kind of starting to finish all this process, let's run through the shift, do your shift enter after you did the model.fit. Let's actually run through the rest of it. So this part and also the deployment part. So run to the piece before the last line where you're actually creating a model server. So you're creating a server. And then what you're doing is that you are running a query against it, against the actual remote server. And once you've done that, we will kind of reconvene. So run it to the line right before the end of the script, so that we have a little bit of time to continue the conversation. And for those of you who are, want to take a break, feel free to take a break for about 10 minutes.
I have a question about multi-headed attention.
Yeah.
Is it, when you have a bidirectional model, can you put the attention in different places going forward and backwards?
So Rachel, you want to explain that?
Yeah, sorry. Can you repeat?
Yeah. So when you have a multi-headed attention and you have a bidirectional model, can you have attention that's in different place for forward and backwards direction?
Or do you mean for different place?
Like, you know, like say, I don't know, on the nouns for going forwards, on the verbs going backwards.
Yeah, so when you're training, it's like you're feeding your input like for both direction, and your model will just learn it. It's like you will just have those like transformer models. So like those transformer block, remember? So for each block, there are those multi-head attention inside of it. And what we do is like we feed the input in those transformer block, and there are those parallel attentions. So the parallel attentions doesn't really care about what the sequence do we fit. You just fit a sequence because the only position which you're trying to encode, the position is a positional encoder. And the rest, you will just parallel train everything. So it doesn't really matter how are you going to fit it. But when we train the bird, we really train the context from both directions.
Yeah. So what I wanted to do is to you know, there's a lot of more details in here, and what I was trying to get is to do the positional encoding. I mean, this is just code, but I wanted to get a picture of it for you. Let's see. My browser is not responding too well here. Do we have a good picture of it? Maybe it's in the slides. Yeah, here's a good one. So I think I would, you know, start by understanding, you know, this, you know, the single attention model and how the, you know, the query key value works. Essentially, you're filtering out the different attentions or, you know, the positional encoding. And then in a multi-headed attention, essentially you added this, you kind of have like a, you know, row of them to look at different parts of the system. And, you know, it's going to take you a little bit of time to understand how that works. But the key thing is that we provide you with all the, you know, all the code, which allows you to kind of walk through the full process. Let's see. All right, so we're still going to allow folks to take a little break. Why don't we come back in 10 minutes from now? So 1:10. Actually, it's not East Coast. It's 4:10, right? So let's come back at 4:10. That's seven minutes from now. But in the you know, if you have more questions, please feel free to ask us as we go.
I have another question. How big is your training data set? I see one epoch, it's just maybe less than 10 minutes training. Do you use the full squad data set?
I think it's a partial one. Let's actually take a look to see how big it is. So if you go to the original training, it actually tells you how much it is when you download it. So go to your training history, and you will be able to go back to like the original data set. It's, oh, oops. Yeah, so you see the little JSON file that we're downloading.
Yeah.
So typically they're about like a gig or something, so I remember. So this is actually not that big. It's only like 200 megs. Yeah, so it's probably not the full size. Let me actually take a look real quick. Yeah, that's right. Yeah, and you can go find this on their GitHub, right? So you can just, oh my God, you just saw. So just do just go to their website and it will tell you how big it is. Oops. But if you download the whole thing, it will tell you, you know, what the size is, about 200 meg. Yeah.
Oh, yeah, thanks.
Yeah, of course, you know, you can have your own. It's not that, I think it's like just a few thousand questions. I mean, if you think about it, like if you have a training data set and like how much can humans actually annotate, right? It's not that much. So I can give you an example. So like I just was working with some folks over at Alexa. So I asked them, there's Alexa in the background hearing me. So I asked them, how big is the data set you want to, train for your utterance? And it's not that big. It's 30 megabytes, 20 megabytes. So that's the beauty of natural language processing models, which is you can actually fine tune them without a lot of data. I mean, that is really the key here. That's why these language models are so successful. So we talked about the fine tuning doesn't need a lot of epochs. You need like 4 or 5 epochs. And then you don't need a lot of data sets either. You need a small amount of data. And then that, would be able to give you really, really good accuracy. Because the model itself has already captured a lot of the nuances of the actual language, the human language. I would like to even make a statement saying that human language models are complex, but if you remove all the referential pieces of it, meaning that let's just say the Bible has references to biblical stories of other things. If you have specific references to things that are not represented in text, like images, we also talk about culture, right? Culture is not just a representation of language. It's much of. I remember I was telling people that much of our culture is not written, right? So there's dances, things that people kind of make assumptions of. There's food you make. There's other things that you do. So language is a very small part of our cultural references. So the model itself is not as big as we think. So neural networks are able to capture most of the complexities of the language itself, but it's probably not going to be able to capture the references to like culture and other things that are not written. So like for Q&A, for questions and answers, we don't really do a lot of writing. Our text responses are not like, they're complex. An average of a text response for a voice interaction with Alexa and other things is like, I don't know, 6 to 10 words. It's not that big. So just to give you a kind of an understanding of this.
Yeah, it makes sense. Because I guess the BERT pre-trained model already kind of captured the context in their sort of training. Yeah. That's
correct. Yeah.
Thanks.
Yeah, and going back to the original question, like the run squad and other things. But if you
that's okay. Yeah, I'll look more into.
Yeah, you can more. These are like just complex scripts, but like basically for most people, you just take it and use it, and you will be able to take advantage of it.
Yeah.
I just modified this.
Yeah, sorry, talking about something else. Would you have future session about your auto ML capability? Because my company is actually actively looking for the auto ML capabilities.
We can. And the let me actually find. For some reason, this is not looking properly. But like everything you have here is a working set of files, and you would be able to find pretty much everything that you need in here. That it's like working, right? So in terms of AutoML, we are going to have a training. So I would suggest that. In fact, I'm actually going to have a training for internal folks this afternoon. And what I would suggest that you do is to join the Slack channel and make a request there. We will be doing some external training very soon. And the key here is that you just need 3 lines of code to do AutoML. So what a little bit of detour here. So if you want to learn more about this, basically go to auto.gluon.ai, and basically it shows you the 3 lines of code that is required to do training for AutoML. So you first you import your tabular package, and then you run a test.fit. You're going to give it a CSV file, as well as the columns of which you want to be predicting. And then you basically predict. Basically, you run the predict. You can give it, multiple ones. And it's pretty easy to install. And you can just simply install it and run it. And there's tabular predictions. There's image classification, object detection, among other things. But I would strongly recommend that you take a look at the tabular one first. And it's a very good tutorial. In fact, I went through it myself. So there's a Kaggle tutorial, how to quickly get started using Fit. And some folks actually asked me earlier about how well it performs against other systems. So we have a paper out that basically shows all the benchmark we ran, and it is able to outperform all of the other AutoML systems. The only system that it did not outperform was an ensemble of all of the AutoML systems. So there's a UBC. So UBC team under Frank Wood, they published a paper that basically did an ensemble of all the AutoML systems working together that was able to outperform our system. But that's really an ensemble of ensembles. But if you want to just use one system, instead of having to manage 10 different AutoML systems, this is going to give you the best results as always in terms of accuracy. And of course, we also have things like distillation. So we have a new paper that we published, and it's about taking the final results of the ensemble models and distill it down to a neural network model that will allow you to be able to do inferences relatively at ease. So there's a lot of different things that you can do with AutoML. So we're going to be doing a major restructure of this system. So we're going to be releasing 0.1 at some point in the next 2 months. And along with potentially some data sets that we have internally for folks to try out.
Okay. All right, thank you.
Yeah, okay.
Sorry, I have a question.
Yes.
So you showed in the notebook that you have like a SageMaker.pytorch. What if you want to, let's say, train using a different package like Hugging Face?
Yeah, so there are containers that would work with Hugging Face, and what I recommend that is you take a look at all of the like sample notebooks that we have. So this is, this is a specific notebook, but if you go up to where you started, I have to move this little title bar on the side here. So if you want to get started, so there's this SageMaker samples directory. And you'll probably find Hugging Face in here. I think you can. It's just that I have to go through all the different listings here. You'll probably find it in here. There's an example somewhere. So the reason we actually used the NGC, among other things, is that it was working. Like we know that it works. We had to make some minor changes to it, but it does work. It also was part of this. Let me take a look to see if there's PyTorch here.
Yeah, just share a link in the group.
Yeah, additional examples on GitHub. Do we see Hugging Face in here? Yeah, I know Hugging Face is in one of these examples. There's lots of examples. Gosh, I wouldn't know. Like there's dozens of people contributing content all the time. So, but also you can just search on our GitHub repository. Like all of these things are actually on the GitHub somewhere. If you go to AWS Labs, GitHub, you can search for GitHub AWS Labs. Yeah, so there's, AWS Labs. You will be able to find like all of these things in here. So I would, there's a bunch of people copying stuff. Let me go back again. Just go to GitHub, AWS Labs. So we'll be able to find all these examples in here. Oops. For some reason, it's not reaching properly.
I think you missed the .com.
Oh, yeah, .com. There you go. Yeah, so you can see that you'll find all of these. It's like, for some reason, AutoGluon is always one of the most popular ones. So let's actually look for Hugging Face. Or you can just directly search for Hugging Face and under Google, I think.
There is no space between.
Oh, there's no, okay. Interesting, it's not in here. Rachel, did you just put that in the chat room?
I put a link, but I haven't found any notebook about using.
Yeah, so I know there is one.
Right, go ahead.
Yeah, so there you go. So hey, look, there's one here. There you go. Let's see. Yeah, you'll be able to find like examples that people may have done already. Let me see if this is one of them. Is this Hugging Face? Yeah. Sorry, I don't have these. I don't have it readily available. But another thing is that look at the AWS machine learning blog. Gosh, there's like hundreds and hundreds of these. So let's look for here. Yeah, there's some of them here. So maximum NLP. So that's probably one of them. That was the original. There you go. Hugging Face. So you might be able to find some of this here. There's lots of different. So let me just paste this in here in the chat window here. All right. It's probably the same one that Rachel posted. Okay, so back to where we were, since we only have just a few more minutes here. Let's see. So I think what I did is I've already deployed my model. As you can see, just give you a little feel of how these things work, right? So first of all, we did the training, which used 4 GPUs. And if I were to use 1 GPU, it will take an hour or more. So there's a little bit of overhead for downloading the data set and doing some pre-processing among other things. But when it comes to doing the actual training, it does scale fairly well. So the wall time itself is 25 minutes, but the training itself, excluding downloading, is probably like more like 15 minutes or so. So if you were to do this using 1 GPU, probably take you an hour and a half also to do the training. So for the deployment, there is the deployment call, right? So there's just essentially just model.deploy. You create your model and tell it where your model is actually at. And the previous, in the training step, we actually had this model and had that uploaded to the S3 bucket. And you can actually go directly to the S3 bucket and find this model. You can copy it anywhere you want and basically do inference on-prem anywhere. So it's not just specific to SageMaker. The SageMaker just saves this into a location for you. And the next step is to just tell it to use one of these instance type, the G4 DN, to host it. And once we've hosted it, it takes about 12 minutes to spin it up. Usually it takes a little, about 5 minutes to 7 minutes, but this time it just took a little bit longer. And we're hitting the model endpoint here by asking it the question. Did it actually run the questions?
You can create your own question. Feel free to
Yeah.
do anything.
So, all right. So let me actually, did it run? Okay, for some reason mine didn't run. Rachel, do you want to show yours when it's actually finished? For some reason,
sure.
mine didn't work. It should
Did you
have.
train?
Yeah, it did train. So yeah, it's just so. But let me actually show you one thing before Rachel takes over the screen. It's actually over here. If you go to the SageMaker page and you can go to the endpoint endpoints, I should have an endpoint here. So it does have an endpoint. So that is actually in service. So it is running right now. And let's see.
Oh, I think I know why. I think I did something wrong. Sorry. I think I shut down. You just need to print that line. So now you have to pass in your data. And you just need to add an extra line there and print there.
Oh, did print? Okay. Let me just go back to where we were.
So
okay,
let me, sorry, I think I did. Let me just paste it here.
Yeah, just paste
So
it in
I
there so
paste
that
it
everyone
in
can
the
run it.
blog. You just need
that's
to
right.
run
Yeah, that's
back
right.
one again to return your response. Yeah, I just did some handy fix and today something wrong yesterday. Sorry about that.
Yeah. Okay. So let me copy this. So this is correct.
Yeah, so
Just want to make sure
basically
that
you need to fit your data and fit a JSON file with this content type as application-JSON.
Let's see. Oops.
You
Sorry.
need a new style. Just a new.
Okay. Why don't you show your screen?
Yeah, I can do that too.
Yeah. So that make sure that everyone actually has this line properly.
I will share my screen now.
Yeah, I'll stop sharing. And then you might want to copy this, just paste the right line in there. This is definitely not the right line.
Oh, it's in? I think I did. So you just need to add a new cell because you have the time.
Yeah. Okay.
To run that. But can you make me
All right.
host
Why don't
first?
you walk folks? Yeah. Walk people through this.
Yeah. Can you make me as host?
Yeah, I did. First? Yeah. So just add a cell and run this. Yeah. So I'm actually running it now.
Because I think you're still the host, or who else is still the host?
I made you the host.
And I don't know what happened. I cannot share my screen.
Yeah. Okay, I just made you the host again. Try it now.
Okay, so I like you. Where is my screen? I think this is the one. 13. Okay. Can everyone see my screen now? Okay, I add too much. So basically, if you're down the deploy, you will see this small dash, and it will tell you how long does it take to deploy your model to this new G4 instance. And after that, we can start testing our endpoint. So now what we're going to do is we're going to fit in this context and our question. So our question is for last time, and our context is blah blah, a paragraph coming in, and we're just going to put them in this JSON format as passed-in data. And with this data, we can just call our endpoint, which is the endpoint we just deployed previously, with data as our data and the initial arguments with this exactly this file, so content type, which is application-JSON, because back into the code, when we run the scope code, the application.json is only a separate format. If you throw in the other format as initial arguments, it won't accept it. And then you can just print your response from the bird endpoint you just deployed. So now, as we just said, we can just run it again. It will take a little bit time to run it. As you can see, it's super quick. So basically, what is returned? You can say there are several answers here, but this is just our demo to show you what is happening behind the scene. So basically, the first answer, it returns just one single token or one single word. It's a several, which is what it should be. And then it has like the probabilities, like how confident our model is. And then it also the start logic and the end logic. So the start and the end, we can use the second example to understand the start logic and the end logic. So basically, what does it mean is like back to our context, back to our paragraph. Our model is trying to predict, oh, is this first one the start answer I'm going to output, or is the second one, or is the third one is a start? If it is, then it will just mark this word as oh, it will be the start tokens of my answer. And just like goes through, and predict which will be the end tokens of my answers. For example, the second answer return us with a super low probabilities, like 0.12 probabilities of confidence, to think like, oh, this sentence will be answered. So how does it find it? So he will just think, oh, this will be our start tokens, and then moving to Tom, it will be the end tokens. So and our models will then extract from start to end to extract the whole sentence out. So that's the basic idea of how the QA models do the back processing or like trying to find the answer for us. And then as you can see, we have like all these different answer. And if you really just want one answer, you can just output the highest probabilities answers based on your choice. So that's it for the bird training. And one quick tip is if you want to continue working on your script after you made some modifications, you can zip the file, or also please delete the endpoints after you've done the serve. Or if you try to deploy on the same endpoint, it will cause you a little bit error. It won't let you deploy. But please delete the endpoints. And so you can view your endpoints over this link here. So basically, what happens to, okay, I can move this to the bottom. So basically, you can find your endpoint. As you can see, here's my endpoints. It's in service over here, but you can find your own endpoints at the endpoint section. So on our left. And one quick tip. So if you want to zip the file, you can just you can first. So let's see. So you can zip the whole folders to a zip file, and then you can download the zip file. And later, if you want to continue working on the similar script, you can relaunch a SageMaker instance and on your own account, and just put the zip file and unzip it, continuous working on it. I'm not quite sure what happens to my terminal. Okay, cool.
Rachel, you're breaking up a little bit. I'm not sure if it's your microphone or if it's your network.
I think I was just access to our VPN. So
Yeah, you might want to
VPN.
disconnect it from the VPN.
Okay, cool. I will then just disconnect it from it. Okay, can everyone hear me now?
Yeah, much better. Much better.
Awesome.
Yeah, I think the
Sorry
VPN
about
does
that.
make things worse. Yeah.
Well, it's VPN. It's private. Anyway, so if you want to zip your file, so you probably do ls first. Oh my god, where's my? Let me connect to this guy again. Okay. So let's find where we are. Let's do pwd. Okay. So what we want to do is first, we probably need to go to delay that guy. So we're just going to delay that. Okay, so I think I also write it on my. So I also write the command line instructions on the workshop tips here. So basically you need to remove those per base model. It will, because it's super huge, you probably do not, or you probably need to remove those guys too. So remove that, remove the bird, PYT guy. Okay, so after you remove them, you will say you can go to zip the help folder. So basically, you find pwd, and I'll probably need to go extra one again. So now you have only one folder, as you can see here. So what we can do is we zip this whole file with whatever name you want to be a folder. As you can see, it's like zipping there and super quick because we do not have those heavy lifting models to zip in. And now moving back to our folder, you will see the zip file and you can just download it. Just click it, download it. It will just download. And later, if you want to rework on it, you can just go back to re-import this whole folders and continue with your work.
Yeah, and you can continue to train it if needed. But yeah, I think that's a good good point for us to wrap up. Thanks, Rachel.
Yeah, I saw someone saw I saw things.
Yeah, I've got a slightly different. Yeah, do you set the redundancy somewhere?
Yeah.
Where I invoke like
it makes sense. It totally makes sense. That's how neural networks work.
Yeah, it depends on how you
initialize the ways. Like how do we try it? Like there are those like small randoms, but as you can see, it's just like 0.5 difference. Yeah, there's 0.5% of difference overall.
Yeah.
So
that's normal.
Sometimes I would say like for different model, different version of training.
Yeah, but have you attempted to set redundancies for some of the model initial parameters? Like,
I don't think I set random seed
okay
anywhere, but a good tip for you if you're going to train something like train from scratch, always set the random seeds. Because then you can compare your models from other dropout. You just add extra layers there, and it will help you a lot with this random seed to compare different models. Since now we have all the initializations to be the same ways.
Yeah,
but that's a great question.
Yeah. Okay. Yeah. Thank you.
Yeah. So everyone's is a little different. So thank you, Rachel. And let's try to wrap it up. And well, first of all, I want to thank everyone again for attending this, and you already have access to all the slides. So keep in mind it's 2.5 hours, so we had to kind of reduce a lot of the, abstract away a lot of the complexity here for how these models work. But one thing is that if you were to try to do this from scratch, It's going to take a much longer time. So think about what we've done today. We've actually spun up infrastructure to be able to fine tune a BERT model using Squad, using 4 GPUs to be able to train it. We built a container, and that container was actually used to do distributed training on a separate cluster, as well as being able to host it on SageMaker endpoint. So that was a lot of work that would probably usually take an engineer a few months to be able to get working end to end. So we took 2.5 hours, or actually less. So if there are any more questions, feel free to ask us. We're going to be here for another 10 minutes or so. And we also have our emails here displayed, so feel free to reach out to us if you have any additional questions. Yeah, I just keep in touch, and I know a lot of you added us on LinkedIn, so be very happy to continue the conversation and the journey for deep learning with you guys, and hopefully we'll see folks in the future events. So here we're open for questions. Rachel, you want to add a few things?
Yeah, I think I'm good for now. I think we're just waiting for questions if anyone has questions. But thank you again for joining us. It's a great journey.
So I have the easy question. So how do you
Yes.
download the whole directory?
You can just zip up the whole thing and download it.
I don't see the download, like find on files.
Yeah, so let me just share my screen real quick.
Okay, thank you.
Rachel, you want to share? Let me share my screen. Okay, cool. Let me try to do this. Rachel? Okay, I can't share my screen. I think she left already. Oh, now I am host. Okay, so
Hear me?
she's back. Yeah, she's back.
Can you hear me?
Yeah,
sorry,
yeah.
I was
No,
mute.
it's okay. Yeah, so the way you do this is you go to your Jupyter notebook, right? So you definitely want to add a new terminal window, and you'll go into the terminal window, and I think Rachel was showing you this earlier. So you want to say zip.
Oh, you zip it. Okay.
Yeah, just zip, or you can do tar. It doesn't matter. So go to SageMaker. Say mine is a little slow here. So you want to say zip tmls 2020 dot zip, then tmls 20. Oops. I like to use tar, so tar cdf this thing, the tar gz this thing. So cz. So you see the command here?
Yep.
So just do cz and just do that, and it will add everything in there. If you want to basically download the whole thing, it's going to take you a few minutes, and then you can go back to this and find it. You'll see the zip file there.
Oh, no such file. Okay.
Just make sure you're in the SageMaker directory. Yeah.
I'm in TMS 2020.
I also read the tip at my GitHub README file. So for this zip line, you can just copy that. Yeah, but thank you, Wimi, for showing.
Yeah, sure. Let's see. So, I mean, this is going to take you a little while to do tart GZ, the whole thing. So I think Rachel was removing the base model and some of this stuff, but the overall, I think that's like 8 GB of stuff. I think we may also have included the image file that the Docker commands actually created. So it's going to be a while. So, but don't worry, we're going to leave this system running for a couple of maybe another hour or so. So I won't turn it off until 2:30, I think. So that's like 6:30 your time.
Okay. Yeah, because I do it and then it says cannot stat, no such file or directory. So
what do you mean?
I did the tar minus CZVF to get the
so do a
simultaneous
PWD. Are you in SageMaker directory?
I think so.
The CD SageMaker first.
Oh, I am on T. I went one level too far. Okay.
Yeah.
All
So
right.
it's done, and this thing is like for my keyboard is, so it's like 5 gigs.
Okay.
So you just download it.
Awesome. Thank you.
Yeah.
I got it already. Thank you very much. Thank you.
Yeah.
It was a great presentation. Thank you very much.
Yeah, you're very welcome. Anyone else has any other questions? Okay, good. That concludes our tutorial here, and feel free to connect with us. We're signing off for now.
Yes, thank you everyone for joining our presentation today.
Thanks, Rachel.